while we jump into the concepts of hard disk, and then we would discuss some of the thriving problems that have been that resulted into very popular, some of the most popular research articles that we have seen in a couple of previous decades. And people learned from that. We adopted the knowledge that was provided by the original authors of those articles in those articles when they were published. And somehow we adopted those techniques, the way of solving those problems that they pointed out in those papers, into our routine, most of the operating systems that we use today. So who knows, something that the new knowledge that you come up with today could be used by people in upcoming decades, and you'll be proud of that, right? So are you ready to squeeze your mind, maybe come up with some new ideas while we talk about some of the great ideas that lived before today? Okay, so let's start with what does this hard disk consist of? If we open the hard case of the hard disk, which we see outside, what is it that you would find inside? I'm not sure if some of you have been courageous enough to take a hard disk, rip it apart and peep inside. But if not, then this diagram should give you a better idea of what is it that you would see if you rip open a hard disk. So here we see that as clearly labeled, all the hard disks have, usually most of them today have different components such as a processor on chip. Inside the hard disk, it has DRAM and an control ASIC controller, IO controller. And thus, with all these components, we could say that a hard disk is a small computer by itself, right? Physically, it has different components like multiple cylinders. Definitely, hard disk has multiple cylinders as opposed to single record, which magnetic discs, which people used to use to hear music. In olden days, you might see it in some of the old movies or old web series today. That used to be just a single disk, while hard disk is much more efficient than that, and hence it has been living for so long, so many decades, right? We have not come up with a better replacement of hard disk, and that's where we have been just improving hard disk, the way of using it, but still using hard disks. So it has multiple cylinders within it. Each cylinder has two arms actually on the top and on the bottom, because each cylinder has two surfaces, upper surface and the lower surface. Now, each platter has multiple cylinders. So as we see that this is a platter, each platter has multiple cylinders, because we can have this vertical line across, ranging over multiple platters. We call this thing that's marked in cyan, we call that as track. You could compare this to your running track, right? It looks the same, the sports running track. And then we call different components within the track something like this as sector. Usually sectors are fixed size of data. In most of the hard disk, many hard disk manufacturers and vendors agreed for a sector to be 512 bytes. And the read-write head is definitely responsible to read the data from the given sector and write the data to the given sector. Now, each of these plates in hard disk rotate as we see here with this rotation direction. While rotating, the position of this arm head, wherever the position is located, we are able to adjust the position of this arm head to read the data. So there are two basic motion that we are doing in order to read and write data into different sectors located across different tracks and across different sectors within a track. These two operations are, first is seek, where we move this read-write head backward and forward across the tracks. So something along this path. If we are moving across the track, right, that's seek. And the second motion that we are doing is rotation. So each of these disks is rotating across this center spindle. And while it rotates, we are able to access different sectors on the same track. While with the seek movement, we are able to access different tracks. So while we could have this series of diagrams shows how different operations could be performed. Let's say we just completed reading the blue sector. So after reading blue sector, we would see the position of the disk would be something like this. And let's assuming the rotation direction as this one. Next, if we want to seek for red, then definitely we have to move this head to the outer track, right? So hence the new updated position of the head is shown over here. Pardon my notification. Then once we seek for the track of that red sector, then we have to rotate, right? So if the rotation direction of the disk is this, so then we are rotating from here to here, right? So the grayed out area in the third diagram shows the rotational latency. And finally, we are at the head would be positioned at the beginning of the red sector, which we want to read. So we just complete reading that. So that's the data transfer. Thus, the total IO time could be represented as a summation of tseek, time that it takes to seek the data, move the header to the respective track, plus the time that it takes to rotate. So rotate the disk until we reach the required sector on that track. And finally, to transfer the data. So to read or write the data from that sector. Now, once we have the time that it takes to perform the IO, if we know the size of the data, so size of the data that we are transferring, then we can calculate the IO rate as size of the data divided by time it takes for performing this IO operation. So the units of IO rate is, what is the unit of IO rate, or what would be the unit of IO rate? Something in terms of bytes, because data size is in terms of byte. It could be byte, megabyte, kilobyte, gigabyte, terabyte, anything, something in terms of byte divided by the time it takes for the IO. So there, the key is in the unit of time, could be seconds. So something in terms of byte upon something in terms of second, bytes per second. When you go to buy hard disk, you would have seen the terminology like bandwidth of this hard disk is 100 gigabytes per second or something like that. So that's exactly the what it represents is the IO rate for that hard disk, average IO rate for that hard disk. So if you perform many such IOs on an average, how would this hard disk be performing? So 3 important things to remember is the seek time, the rotation time, and the data transfer time. That gives us the total IO time. And once we have the total IO time, we can, if we know the size of the IO, then we can calculate the IO rate